Hello everyone, myself Hans. Today we are going to solve the problem of UPSC Maths Optional Indian Forest Service question from topic area of the ellipse. Here in the question, find the area enclosed by the curve in which plane z is equal to 2 cuts the ellipsoid. Here ellipsoid is given. Let's solve the problem. Given ellipsoid is this is given by x square upon 25 plus of y square and plus of z square upon 5 is equal to 1. This is the equation of ellipsoid, and the curve, the plane cuts the ellipsoid, and then the plane cuts the ellipsoid at z is equal to 2. So we have to satisfy the equation of ellipsoid. We have to put in place of z, that is 2. Then the equation of ellipsoid becomes putting z is equal to 2 in the given ellipsoid. Then equation of ellipsoid becomes we have to put in this is x square upon 25 plus of y square, and in place of z square here we have to put here 2. This is 2 to the 4, that is 4 upon 5 is equal to 1. And from here we can also write this is x square upon 25 plus of y square, and 4 upon 5 is taken to right hand side. This is given by 1 minus of 4 minus 4 upon 5. We have to solve here. This is given by taking LCM. This is 5 minus 4 upon 5. This is 1 by 5. And we have to write also multiplying 5 with the cross multiplication. This is written as 5x square upon 25 and plus of 5y square is equal to 1. And from here we can also write 5 5 is 25. Then the equation of ellipsoid becomes x square upon 5 plus of y square upon 1 upon 5 is equal to 1. And we have to find the area of the given ellipsoid. We have to find the area of the ellipse. Area of the ellipse. When we have to put in the z is equal to 2 in the ellipsoid, then the equation of ellipsoid becomes the ellipse, and it lies at xy plane. So we have to find the area. Area is given by area. This is given a double integration of dx dy, and from here we have to find the limit of the given integration from the ellipse. We can put, first we have to put x is equal to 0. First we have to put y is equal to 0. Once again, when y is equal to 0, we have to put in the given ellipse. Then we have to write here this is x square upon 5 is equal to 1, and this gives x square is equal to 5, and here is x is equal to plus minus of under root 5. And we can also put here, when we have to put, once again, from here we can find the value of y, and y we have to find putting y square upon 1 by 5 is equal to 1 minus of x square upon 5, and here 5 multiply 1 by 5 multiply with this side. This is given by y square is equal to 1 by 5 minus of, we have to multiply with the 1 by 5. This is given by, once again we have to write in 1 by 5. This is x square upon 25, and from here we have to taking LCM. This is 25. 5 5 is 25. This is 5 minus of x square. And from here we have to get the value of y. This is y is equal to under root of 5 minus of x square upon 5. This is the plus minus here. Also the value of y is plus of under root 5 minus of x square upon 5 and minus of under root 5 minus x square upon 5. We have to put the limit here. This is given by area is equal to limit of x. First we have to put the limit of x. The limit of x is given by here minus of root 5 and the upper limit is plus of root 5, and the limit of y is given by here we have to calculating. This is under root of minus under root of 5 minus x square upon 5, and here plus of under root of 5 minus x square upon 5. This is dx dy, and further we have to integrating once again. We have to integrating. This is area is equal to, we have to integrating y with respect, integration of dy is y, so we have to the integration limit is minus of 5 under root of 5, and here we have to integrating y. This is given by y and putting the limit here. This is minus of, we can also once again we can also change the limit 2 times the limit, both of the limits of x and y we have to convert 2 times of the limit. This is given by first for x and second for y. This is written as 0 to root 5, and the second limit is given by 0 to, we have to rough here. This is second limit is given by under root of 5 minus of x square upon 5. This is dx dy, and further we have to solve. Further we have to solving. This is area is equal to 4 and integrating y dy. This is given by integration 0 to root 5 integration limit of x. This is dx, and integration of dy is y, and we have to putting the limit 0 to under root of 5 minus of x square upon 5. So we have to put here. This is given by 4 times of 0 to under root 5. Here we have to put, this is given by under root of 5 minus of x square upon 5 dx, and from here we can also write 5 is taken into outside. This is given by 4 upon 5 under root of 0 to limit of 0 to 5, and here is 5 minus of x square under root dx, and from here we can also apply the formula. Once again we have to let here, let x is equal to 5 root 5 sin theta, and from here changing the limit here. When we have to put x is equal to 0, we get x is equal to 0, then theta is equal to 0. When we have to put x is equal to root 5, then we get theta is equal to pi by 2. When we have to put here x is equal to root 5 is cancel out, a sin 90 value is 1. So we have to change here. We have to putting here, this is area is equal to 4 upon 5, and the integration limit is root 5 to, once again integration limit is 0 to pi by 2, and in place of under root of 5, and we have to let here x is equal to root 5 sin theta. On squaring, this gives x square is equal to 5 sin square theta. So we have to put here 5 sin square theta d theta, and we can also put the value of d theta once again. We can also put the value of d theta from here. This is given by dx is equal to root 5, and the integration of sin theta is once again dx. This is on differentiation. This is sin theta is cos theta d theta, and from here we have to put the value of d theta also dx. This is dx is given by root 5 of cos theta and d theta, and further we have to solve taking root 5 into outside. This is given by 4 root 5 upon 5, and this is 0 to pi by 2, and here we have to also take a common 5. This is 5 with taking common 1 minus of sin square theta, and here is cos theta d theta. When we know that from trigonometry 1 minus of sin square theta is cos theta. This is given by 4 under root of 5 upon 5, and we can also taking outside root 5. This is 0 to pi by 2, and 1 minus of sin square theta is cos square theta, and cos square theta is taken to root. This is cos theta. This is 5 cos theta into cos theta. This is cos square theta d theta, and further we can also write here once again here is root 5, and here we can also write 4 root 5 into root 5 is 5, that is 20. 5 into 4 is 20 upon 5, and this is integral limit is 0 to pi by 2 cos square theta d theta, and from here we can also write 5 4 is 20, and further we have to solve once again. This is area is equal to 4 times of 0 to pi by 2 and cos square theta d theta, and we have to use the formula of beta gamma function from. This is given by integral of 0 to pi by 2 sin to the power of p theta and cos to the power of q theta d theta is equal to gamma p plus 1 by 2 and gamma q plus 1 by 2, and this is given 2 upon 2 gamma p plus q plus 2 by 2. Here p is 0 on comparing, and q is 2. So we have to put in the formula once again. This gives area is equal to 4 times of, we have to putting in place of p. When putting here p is equal to 0, this gives gamma of 1 by 2, and here we have to put in place of q is 2. This gives 2 plus 1 by 2, and upon 2 gamma of in place of p we have to put 0, and q is given by 2. This is 2 plus 2 is 4 upon 2. This is gamma of 2, and further we can also write this is 4, and here is gamma of 1 by 2, and here is gamma of 3 by 2, upon 2, and gamma 2 is also written as gamma 1 plus 1, and this is n gamma n. The gamma 2 value is 1, so we have to write here 1 here, and from here once again we can also write 4 upon 2, and here is gamma of 1 by 2, and gamma 3 by 2 is written as once again gamma 3 by 2 is written as gamma 1 plus of 1 by 2. Once again we have to write 1 by 2 plus of 1. This is the form of gamma n plus 1 is written as n gamma n. So we have to write here this is 1 by 2 into gamma 1 by 2 in place of gamma 3 by 2. This is written as 1 by 2 into gamma 1 by 2. Up here 2 2s are 4. we have to cancel out, and gamma 1 by 2 and gamma 1 by 2 we have to write once again. Here is 2 is also 2 is taking 2 to 2 is cancel out, and from here gamma 1 by 2 the value is root pi, and again root pi, this is given by pi. The total area is given by pi. The area enclosed by the curve with the plane z is equal to 2 cuts the ellipsoid is pi. Thank you class, and thank you for watching.